Good day, viewers, and you are welcome to ML2 channel. This is Engineer Oladipo, your host, and you are maybe online tutor. So this session will focus on Cambridge Igcse Physics multiple choice question, precisely May June 2025. Without wasting time, learners, let's quickly dive into details. And today I'm going to show you how you can excel in your Igcse exams and come up with scoring A in your exam. So let's get started. We have the first question, question 1. The diagram shows a measuring cylinder containing liquid. So here comes the question. What is the volume of the liquid in the measuring cylinder? So identify the problem. The problem is we want to measure the volume of the liquid that is present in this measuring cylinder. So how do we do that? To do that, we need to get the graduation or the calibration of the measuring cylinder, and the cylinder is actually calibrated in cubic centimeter. So let's check the interval from the origin here, which is the starting point, to 10 cm cube. We have 5 intervals. So we'll do 10 divided by 5. So that gives us 2 cm cube. So that implies that each of those small intervals represent 2 centimeter cube. So if we start counting, this will be 2, this is 4, this is 6, this is 8, and this is 10 cm cube. Then if you look at the liquid, the point where the liquid is here. So we continue counting. If this is 10, then this is 12, this is 14, and definitely the liquid is on 16 cm cube. And that makes option C to be the correct option in question 1. All right, learners, so let's quickly move to the second question. And in question 2, read, which statement about speed and velocity of an object is correct? So here our focus is on speed and velocity mechanics. So I repeat the question. Which statement about speed and velocity of an object is correct? So we have option A. The speed and velocity of an object are greater than 0. That's incorrect, because if an object starts from rest, it has initial speed u, which is equals to 0 meter per second. So option A is definitely incorrect. So let's look at what we have in option B. The speed of an object is always greater than its velocity. That's also incorrect. Speed and velocity can be the same. So option C, the velocity of an object is equal to a speed in a given direction. Exactly, that's the correct answer. Speed is the distance traveled per unit time, while velocity is the speed measured in a given direction. Then let's see the last option. Speed can be measured in meter per second, but velocity can only be measured in kilometer per hour. That is also incorrect. Both speed and velocity can measure both in meter per second as well as kilometer per hour. So the correct option in question 2 is actually option C. Okay, right, learners, let's go to the third question. And in question 3, we have a table. The table shows a student times in 3 races. Okay, so we have the first race, we have the second, and we have the third. Then in the first race, the distance is 100 meter, 150 in the second, and 200 in the third race, and we have the corresponding time as well. So here comes the question. What is the order of the students' average speed in each race, from lowest to highest? Okay, so identify the problem. The problem we want to solve here is to get the average speed in each race in ascending order. So now to do that, we have to calculate the value of the speed in the corresponding race. And to get the speed, let's put the formula of speed. Speed is equals to distance over time taken. So for the first one now, the distance is 100 meters, while the time is 12 seconds. So if we do 100 divided by 12. That gives us 8.33. So definitely, for the first race, the speed of the object was 8.33 meter per second. But for the second one, let's also verify that you have 150 divided by 17. So for the second race, the speed is 8.8. That's around 8.82 meter per second. Then also for the last race, which is the third race, we have 200 divided by 25. And 200 divided by 25, that gives us 8.00 meter per second. So if you have to move in lowest to the highest, that implies you have to move in ascending order. So the lowest is actually the third race, followed by the first race and the second race. And the order, that is, with that order, the correct option will be option D, because option D, we have the third race, then followed by the A, and finally the second. All right, learners, have you guys grabbed that? So let's move to the next question, which is question 4. So question 4 reads, which rule gives the correct weight for the mass when it is at the Earth's surface? I repeat, which rules gives the correct weight for the mass when it is at the Earth's surface? So identify the problem. The problem here is we want to determine the weight that is correct when the mass was given on the Earth's surface. So now to do that, we have to come with the formula of weight, and weight equal mass times gravity. So empty. So now we just need to check. We have the masses. So for the first mass, and okay, we need to identify the value of our gravity. Gravity is on the surface of the Earth is approximately 9.8 meter per square seconds. So that implies that for every corresponding value of the mass, we are multiplying by 8 and checking the value with the values of the weight given. So let's try the first one when the mass was 2 kilograms. Then we multiply that by 9.8. Then that gives us 19.6. Okay, this is correct. Then for the second mass, if we should multiply 10 by 10, it cannot give us 1.2, so that's incorrect. If we also, multiply 10 by 9.8, that cannot give us my 1.2, that's incorrect. If multiply 10, also the mass by the acceleration of the gravity is 9.8, that can also not give us 9.8. Multiply 20 by 9.8, that's also incorrect. So the correct option in question 4 is actually option A. All right, let's look at the final question, which is question 5. And question 5 reads, the masses and volumes of 4 objects are shown. I repeat, the masses and volumes of 4 objects are shown. Which object floats in a liquid of density 1.4 gram per cm cube? So the question here is, we want to determine the object that is going to float in the liquid, and the liquid has density of 1.4 gram per cm cube. In order to solve this problem, we need to know the density of the corresponding objects that we have in the question. So density, and the formula of density equal mass over volume. And for us to be able to know the one that will flow, an object will flow according to law of flotation if the density of the object is lesser than the density of the object in which density of the liquid in which the object is immersed. And don't forget, the density of the liquid is 1.4 gram per cm. Definitely, the one that has lesser density compared to that of liquid is the one that will flow. So going with the first question, we have the mass, the mass is 1 and the volume is 0.5. Definitely the density of this will be 2 grams per cm cube. So that can not be correct. So let's check the second one. We have the mass, which is 2, divided by this density, which is 3. I will divide 2 by 3. What do we have? That gives us 0.67. Okay, that's most likely to be the correct option because that density is actually lesser than the density of the liquid. Also, if we divide it by 4, that cannot give us 1.4. Okay, let's verify. Then let us work on assumption. So we have C divided by 4. So what's that equal to? That's equals to 1.5, which is greater than the density of the liquid, so that cannot float. Also, the final option in option D, we have 9 divided by 6. So, and that gives us 1.5, which is also greater than the density of the liquid. So the correct option here will be option B, which has lower density compared with the liquid. All right, learners, this will be the final question that we shall be taking for today's session. So I'm giving you question 6 as assignment to try. So let question 6 read. A car is driven from rest along the straight road. The car engine exerts a constant driving force. The diagram shows the horizontal forces acting on the car. The resistive forces are proportional to the speed of the car. So we have the driving force from the engine and we have the resistive forces. So why does the car eventually reach a maximum speed? Option A, the resistive force decrease to make the acceleration of the car negative. Option B, the resistive force decrease to make the acceleration of the car 0. Option C, the resistive forces increase to make the acceleration of the car negative. Option D, the resistive force increase to make the acceleration of the car 0. So you guys should lay your hand on that question and you can actually submit that to our mail, and our email address is askmlttutors@gmail.com. All right, that will be all for today's class, learners. At MLT Tutor, we specialize in preparing candidates for international exams such as GCSE and IGCSE, AP, etc. You can book a free trial today and have a personalized one-on-one excellence tutoring. So that will be all, and I remain my humble self, and in your host, and your amiable online tutor. Bye for now, and take good care of yourself. Bye.